8 minutes into rollout, and as you can see, our crawler team is still focused, working really hard to get SLS and Orion out of the vehicle assembly building. You know, this is years in the making, this operation, with John Giles here leading the way. He oversees our crawler team with NASA's Exploration Ground Systems Program, or EGS, here at Kennedy. Thank you so much for finding the time to talk with us, John.
Very much welcome.
And I just got word that the crawler has crossed the threshold
Yes.
of the VAV. How does that feel? I'm so excited. You should be excited. You're relieved.
Inside, I am very excited.
Awesome. That's great. Yeah, talk to me about where we are in the operation. You know, there was a little bit of a delay today. Can you walk us through some of that?
So we had a couple little delays on some observers. We need many observers to watch us going out to make sure we don't hit anything. So as you can see from all those platforms up there, sometimes it takes a while for the people to get to those platforms. So
Sure.
that held us up for a little bit, and then there was a piece of environmental control system ductwork that was in the way. That was moved, and then we lifted up to 18 inches over the mounts.
And now we're crawling.
And now we're crawling. And I think it was about 5:47 p.m. when I got
Gotcha.
first word we were moving.
Let's turn around and take a look at this. It is crawling. You can see that it's moved quite a bit.
Yes.
How do you feel knowing that you're a part of this team that's making this happen, and we're returning to the moon soon?
It's almost indescribable. I've waited a decade for this since we first started modifying this crawler and getting ready for this. So we are ready. This is so exciting, and even though it's a bit of a long ride out to the pad, I'm looking forward to every bit of it.
Let's talk about this crawler, an impressive machine. It was built in the 60s.
Yes, it was. And the fact that we are still using that today is a testament to all the people that work on it, all the people that maintain it. We have lots of experience with this. We have lots of talented technicians who keep this thing going and maintained. And that's the reason we're still using this piece of equipment that's 57 years old.
And we can see some of the video right here. I mean, this is the crawler that took out, we're talking about shuttle missions, Apollo missions. Talk to us about that.
Every single mission. So Launchpads 39A and B, all the Apollo missions, Skylab, all the shuttle missions, Constellation, and now SLS. Everything that launched there rode on one of our two crawlers.
Wow.
It's the only way to get to the pad.
Yeah, gives me goosebumps thinking about it, the rich history here.
It's given me goosebumps too.
You talk about the fact that there needed to be a number of modifications, right, to make sure that we could support SLS and Orion?
So at the end of shuttle, they came to us and said, we have some new requirements for the SLS program. Bunch of requirements, but the biggest one was you have to be able to increase the weight you can carry.
Sure.
So the original design was for 12 million pounds, so we did a lot of modifications to the roller bearings, to the trucks, to the brakes, to our jacking, equalization, and leveling cylinders, everything, so we can now lift 18 million pounds.
That is a lot of weight.
50% increase over the original design.
Wow. And you guys did that. You made that happen. You know, I also read an interesting stat that the top of the crawler, the surface there, is the size of a baseball diamond. That is unbelievable. And the fact that somebody is driving something that size right now.
So that comes from the bases on a Major League Baseball field are 90 feet apart. So the 4 locations where we intersect or where we mate with the mobile launcher are 90 feet apart. So that is an actual baseball infield. But the crawler is actually even bigger.
Wow.
It's 131 feet by 114 feet, weighs 6.6 million pounds. So it's, in talking with the drivers, it's kind of like driving a super tanker.
Yeah.
It doesn't stop fast. It doesn't move fast. You have to think way ahead when you're going to make turns, and everything is just, we need a lot of people to do that.
Challenging. And a lot of people have many different jobs to make sure an operation like this goes according to plan. Can you talk to us about some other jobs?
So other than the drivers, we have engineers that are monitoring all the systems in the control room. We have technicians, electrical technicians, mechanical technicians, diesel technicians, mechanics. We have logistics personnel in case we need parts. We have lots of observers everywhere because the driver can't see everything as he's driving. So we need other people to follow us and walk with us and tell us we need to start turning here, we need to slow down there. So everybody's on headsets like we are, and they're all talking to each other. It's a huge undertaking to get this thing going.
Absolutely. And that's why, you know, obviously it's going to take quite a bit to get to the launch pad, and we're looking at an 11-hour journey by the time it finally reaches the launch pad. But now that you've explained it, I absolutely understand why it has to take quite a bit. Thank you so much, John.
Oh, you're very welcome.
Good luck with the rest of Rollout. I can't
Thank
wait
you.
to see it on the pad.
Thank you.
Now, the Artemis program is named after Artemis of Greek mythology. She was Apollo's twin sister and the goddess of the moon. Artemis 1 will build on the achievements of those who came before us and create a permanent presence on the moon and inspire our next giant leap to Mars.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
And about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort.
Woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it into drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon, capable of supporting a growing community of efforts.
And we will span the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Everyone, take a look at your screen right now. That right there is SLS and Orion, and it is outside of the vehicle assembly building for the first time ever. It is giving me goosebumps just to say that, seeing it poised there. This is a historic moment, a big moment. We will remember this day for a very, very, very long time. Again, that's a wide shot we have there. You can see it outside. Again, that iconic vehicle assembly building. We have seen Apollo rockets out of there. We have seen shuttles come out of there. Now it is time for SLS and Orion. Crews are moving it all to the pad today for a critical test that will take place in 2 weeks. And joining me now to talk about that test is Cliff Lanham. He is the Senior Vehicle Operations Manager, also with NASA's EGS at Kennedy. Cliff, what an exciting day.
Oh, you can't imagine for this team. We have been working really hard over the last 14 months to get to this point, and the team is beyond excited. We're ready to get out to the pad. There's 21 million pounds of hardware between the crawler and the mobile launcher and the Artemis. We're ready to go.
This must mean so much to your team. I mean, you guys are in charge of really everything, right? Talk to me about what EGS is in your role.
So EGS, Exploration Ground Systems, is one of the 3 sister programs that's responsible for getting us back to the moon. And from our standpoint, we are responsible for development of the pad, the mobile launcher, the crawler, and doing all the facilities and the ground support equipment that's responsible for supporting build-up and testing of the rocket. So we do that, but in addition to that, we're responsible for operations as far as assembly, test, and check out of the rocket. We also are responsible for launching the rocket, and then we're also responsible for recovery of the crew module out in the Pacific after splashdown.
That's a lot. So this is the start of a lot that we are looking forward to. Yes. That's wonderful. And, now the rocket is on its way to historic Launchpad 39B. Yeah, a lot of rich history there.
Right. Oh, absolutely. 39B, actually, it's where Apollo 10, the precursor for Apollo 11, the first moon landing, started. We've done 3 Skylab launches from there, 51 shuttle launches, and also a Constellation test launch. So a lot of action has occurred out there at Pad 39B.
So it's headed out there for a wet dress rehearsal. Can you tell people what that is?
Absolutely. Wet dress rehearsal is a major test for us where we're actually going to load over 700,000 gallons of propellant, liquid hydrogen, liquid oxygen into both the first and second stages, so the SLS and the ICPS in this case. The team will run through a countdown, so they'll start about 8 hours prior to what is called T0, and they'll actually go through their procedures for a countdown. They'll get down below a minute, and they'll recycle that count to practice that as well, up to 10 minutes, and then they'll count back down to less than 10 seconds when they'll stop the test, and that'll be the end of the test, drain the vehicle, and evaluate the information and see how we did.
Yeah, so you guys have to have a successful wet dress rehearsal, right, before we can announce a date for Artemis 1 launch?
Correct. So what they'll do, they'll spend a week or 2 evaluating data. They'll know pretty soon during the test, hey, we're meeting our objectives. But it will take probably, 1 to 2 weeks before they'll be ready to say, hey, the test is fully successful, and we're ready to start thinking about setting a launch date.
Okay. So today is a big day because we are getting to that final test that hopefully soon we will know when Artemis 1 launches.
Absolutely. We're very excited about it. And, again, this is the next big milestone for us, getting to the moon. So.
Yeah. Well, good luck with everything. Good luck with the wet dress. Good luck with the rest of the rollout. And I'm excited. I hope you are too.
I am too. Absolutely.
Perfect. Thank you so much. I appreciate it. All right. We're now about 25 minutes into rollout, and we're seeing more and more of the crawler, the mobile launcher, SLS, Orion. Wow, look at that there. What a beautiful view. And I do want to talk a little bit about the mobile launcher there. That's that structure that you see that's holding up the rocket and the capsule. So the mobile launcher, or ML, is what fully assembled and processed SLS and Orion. The crawler is going to leave both the ML and the integrated rocket on the pad because the ML will supply SLS and Orion with things like power, communications, and fuel before launch. and then SLS will lift off from the ML. And when we fly crew on later Artemis missions, they will use a walkway called the Crew Access Arm on the mobile launcher to get into Orion. Now, like the crawler, there are a lot of people on the mobile launcher right now. There are about 65 people allowed to be on there during this operation, and they'll go on and off as needed. People like engineers, technicians, safety personnel, and the 2 elevators on the ML, this is really interesting, they will be turned off for this operation. So if anyone needs to go to the very top there, that is going to be quite the walk. All right, how about we check back in with the crowd outside? You know, we had some rain yesterday, but luckily the weather today is gorgeous, dry, sunny, beautiful. You know, so many people excited to witness this historic rollout. Again, I'm told nearly 10,000 people are out here, many of them Kennedy Space Center employees with their family and friends. Right now, they can see, again, all of SLS and Orion in its glory. It's just a beautiful sight, and for those out here today, it is a very lucky and blessed opportunity to get to see this outside of the VAB. Coming up, we're going to hear from Janet Petro. She's our Kennedy Space Center director, and after her, we'll have NASA Administrator Bill Nelson. But first, another special musical performance, this time Return to the Moon, an homage to Artemis performed by the University of Central Florida's Symphonic Brass and Percussion Band.